Now this is a review for the complex fraction operations with arithmetic operations, and that means that we're going to use minimal variables in this process and think about how we can simplify complex fractions when they're mostly numerical values. And the idea of simplifying complex fractions is that we want to essentially get out of the form of a fraction over another fraction. And there are a couple of different scenarios that we can be dealing with. The first type we can have is what we see in parts A and B over here. In this case, we just have a single fraction on top and single fraction on the bottom, and that really is equivalent to dividing a fraction by another fraction. And we really can think about that division can be converted into a multiplication right away. So in order to do this, the part A would be equal to 25 over 3 multiplied by the reciprocal of the denominator. So the reciprocal of the denominator is 4 over 5. We're just switching the numerator and denominator on the bottom. And once we get to this form, instead of just multiplying straight across right away, I recommend you start reducing the fraction right here. And here, if we look at the top, we have a factor of 25, and on the bottom we have 5. They both share a factor of 5. So 5 divided by 5 is 1, 25 divided by 5 is 5. And now if we check what's left over, none of the factors share anything in common anymore. So now we can go ahead and multiply straight across. 5 times 4 is 20, and 3 times 1 is 3, and that's going to be our final answer. Now for part B, we would have the x over t all over x over r. And based on this, I can again convert this to be a multiplication by the reciprocal of denominator. So that becomes multiplied by r over x. And same thing as before, we check any common factor for cancellation. Here we can cancel out x and x, and that leaves me r over t as a result. And lastly, for part C, we have this slightly different scenario. We have a fraction on top, or an operation of two fractions on top and operation of two fractions on the bottom. So there are a few different ways we can approach it, and just to prepare for us to complete more complicated expressions over here, what we are going to do is this method of looking for the least common denominator again. And now if we look at the least common denominator, we have to focus on all the denominators we have. That includes all the denominators on top and all the denominators on the bottom. And here we have the denominators being 6, 4, 2, and 3. And in this case, you want to find what they all have in common as a multiple over here. Alternatively, you can kind of think about what's the least common denominator on top and the least common denominator on the bottom, and find the least common denominator of the two. For example, here if we have 6 and 4, the least common denominator we get will be 12 over here. And if we look at the bottom, the least common denominator we would have will be 6. And now if we look at the least common denominator between 12 and 6, we would get 12 is the least common denominator. This is some work you can do on the scratch paper, and you can kind of think about the strategy being a divide and conquer strategy, where we just focus on two denominators at a time if it becomes too overwhelming to think about all four denominators at once. But as you practice more with complex fractions and just generally be familiar with fractions, you will be more comfortable of finding the least common denominator quickly and see it's 12 right away. And alternatively, you can still use a method of either listing out the multiples of each denominator and find what's in common, or use a prime factorization to assist this process over here. So either way, you will get the least common denominator equal to 12. And how we're going to use this factor, or this least common denominator, is we're going to multiply everything by that least common denominator. And that means I'm going to distribute 12 to every term on top and every term on the bottom. Remember, whatever we do to top, we have to do it to the bottom. So that really becomes a result of distributing 12 to every term. So I would have 12 times 1 over 6 And if it helps, you can write 12 as 12 over 1, just so you can keep track of where everything follows. And also on top we would have minus 12 over 1 times 3 over 4. So that 12 gets distributed to the second term on top. And now on the bottom, 12 gets distributed to each term as well. So 12 over 1 times 3 over 2 plus, lastly, 12 over 1 times 1 over 3. And now you can see every single term gets distributed by a factor of 12. And the nice thing about multiplying 12 for everything is we recognize 12 is a multiple of the denominator for every single denominator. And as we do so, we can start cancellation process over here. Here we have in the first term 12 over 1 times 1 over 6. So 12 and 6 cancel out to leave a factor of 2 on top and 1 on the bottom. And then for the second term, 12 and 4, 12 is a multiple of 4, so 4 times 3 is 12, and that's again a 1. You can stop writing the 1 once you get familiar with the process. And just like here in the denominator, 12 and 2, there again 12 is a multiple of 2. So that becomes 6, because 2 times 6 is 12. And lastly, 12 and 3, so 12 is 4 times 3, so a factor of 4. Now if we sort everything out to kind of clean it up for the first term, we're just left with 2 over 1. Minus the second term, we have 3 times 3 on top, which is 9, and we just have 1 on the denominator, so we don't have to write it. And now on the bottom, we have 6 times 3, which is 18. Again, it's over 1, we don't have to write over 1. Plus 4 times 1, which is just 4. And now we are out of the complex fraction form, and that's entirely because we multiply the least common denominator, which we know will be a multiple of all the original denominators, and therefore cancel it out. And as a result, I would get negative 7 all over 22 as the final answer.